Transmission line cable has following primary constant: R 11 ohm per kilometer, G is 0.8 micromoh per kilometer, L is 0.00367 Henry per kilometer, C is 8.35 nanofarad per kilometer at a signal of 1 kilohertz. They calculate characteristic impedance Z0, attenuation constant alpha, phase constant beta, wavelength lambda, and velocity of the signal. So first is calculation of Z0, that is impedance. Calculation of Z0. So characteristic impedance Z0 is given by Z0 is equal to Z by Y raised to half. So this is equation 1. Here Z is equal to R plus J omega L, and omega is equal to angular frequency. Omega is equal to angular frequency, which is 2 pi f, and given frequency f is equal to 1 kilohertz, which is given. Therefore omega is equal to 2 pi into 1k is 10 raised to 3. So it is 2 pi into 10 raised to 3 radian per second. This is angular frequency. Next is question 2. Put value of R, omega and L in equation 2. Therefore equation 2 is R is given 11 plus J, omega is 2 pi into 10 raised to 3 into L is 0.00367. So it is J plus 11 plus J 23.06. Now we can write this in 25.54 angle 64.5 degree. This is equation 3. Now admittance Y is given by the equation Y is equal to G plus J omega C. So G is 0.8 micro, so it is into 10 raised to minus 6 plus J omega is 2 pi into 10 raised to 3, and C is 8.35 nano, so it is 10 raised to minus nano or micro given. It is 10 raised to minus 9. So we solve this equation. It is 0.8 into 10 raised to minus 6 plus J into 52.46 into 10 raised to minus 6. So in angular form it is Y is equal to 52.46 angle 89.12 degree. Now we have the equation of Z and Y. So put equations 3 and 4 in equation 1. So equation 1 is Z0 is equal to 25.54 52.46 into 10 raised to minus 6 angle So this value is 697.86 angle minus of 12.31 degree ohm. So this is Z0. Next part is calculation of alpha and beta. Calculation of alpha and beta. Now to calculate alpha and beta, first we will calculate the propagation constant gamma. So if we write here, to calculate alpha and beta. First we calculate propagation constant. And it is given by gamma is equal to square root of z into y. This is equation 5. Now put equation 3 and 4 in equation 5. Put equation 3 and 4 in 5. So equation 5 becomes, it is equal to 25.549 angle 64.5 degree, and it is 52.46 into 10 raised to minus 6 angle 89.12. So this value is, it is 0.0366 to 6.81 degree. In the form of J, that is complex, that is 0.0083 plus G per kilometer, or we can, so this is equation 6. Now we have gamma is equal to alpha plus G beta. So compare equation 6 and 7. We can directly find the values of alpha and beta. So attenuation constant alpha is equal to 83 neighbors per kilometer, and phase constant beta is equal to 0.35 radians per kilometer. Next is third part. Third part is calculation of wavelength. It is given by lambda is equal to 2 pi by beta. So it is 2 pi by beta is 0.035. So it is 179.52 kilometer. Next part is calculation of velocity. The phase velocity is given by omega by beta. It is 2 pi into 10 raised to 3 divided by beta is 0.035. So it is 179.5 into 10 raised to 3 kilometer per second. Next problem, the characteristic impedance of uniform transmission line is 2040 ohm at frequency of 800 Hz. At this frequency, propagation constant is 0.054 87.9 degree. Then determine R, L, G and C. Now what is given? Characteristic impedance is given. that is Z0. So it is 2040 ohm. Next frequency F is 800 Hertz, and propagation constant, that is gamma, is 0.054 angle 87.9 degree. Now we have the equation of Z0 as Z by Y square root. Therefore Z0 square is equal to Z by Y. So Z is equal to Z square into Y. Now the propagation next step is propagation constant is given by gamma is equal to square root of Z into Y. Therefore gamma square is equal to Z into Y. So Y is equal to gamma square divided by Z. This is equation 2, and the previous equation was equation 1. Now put equation 2 in equation 1. So equation 1 becomes Z is equal to Z square into gamma square divided by Z. Therefore Z square is equal to Z0 square into gamma square. So Z is equal to Z0 gamma, it is 2040.054 angle 87.9 degree. So we solve this and we get Z is equal to 110.16 angle 87.9. This is equation 3. Now the impedance Z, but impedance Z is given by Z is equal to R plus J omega L, and R plus J omega L is equal to 110.16 angle 87.9 degree. Therefore we have to convert it into in the form of J. So it is 4.03 plus J 110.086. Now compare real part of the equation 4. Right here, compare real part of equation 4. Therefore R is equal to 403 ohm kilometer. Now equating imaginary part. So we get J omega L is equal to omega L is equal to 110.086. Therefore L is equal to 110.086 divided by omega, but omega value is 2 pi f. So it is 110.086 divided by 2 pi into f is 800. So the value of L is 0.0219 Henry per kilometer. Now to calculate GSC, consider the equation of admittance. So Y is equal to G plus J omega C. This is equation 5. Now compare equation 2 and 5. So we get G plus J omega C is equal to gamma square by Z. This is equation 6. Now put the values of, we have the values of gamma and Z. So put these values in above equation. Put values of gamma and Z in equation 6. So G plus J omega C is equal to therefore G plus J omega C is equal to 2.647 into 10 raised to minus 5 angle 87.9. Therefore G J omega C is equal to 9.7 into 10 raised to minus 7 plus J 2.645 into 10 raised to minus 5. This is equation 7. Now compare real part of equation 7. So we get G is equal to 9.7 into 10 raised to minus 7 and compare imaginary part. So J omega C is equal to J 2.645 into 10 raised to minus 5. Therefore omega C is equal to 2.645 into 10 raised to minus 5. So C is equal to 2.645 into 10 raised to minus 5 divided by omega, but omega is equal to 2 pi f. And f is equal to 800, so it is 2.645. It is 800. Therefore C is equal to 5.262 into 10 raised to minus 9 farad per kilometer. An underground cable has following primary constant R 45 ohm per kilometer, G 1 micromho per kilometer, L is 1 millihenry, C is 0.065. If the cable is carrying telephone signal, then calculate Z0 alpha and beta at 500 Hz. So in this case we have to use a practical formula application for the underground cable. Now we are not going to write it. Okay, we will write what is given. Given is R is 45 per kilometer, G 1 micro, so it is 10 raised to minus 6 per kilometer, L is 1 millihenry, milli means 10 raised to minus 3 henry per kilometer, C is 0.065 microfarad per micro is 10 raised to minus 6 farad per kilometer, and F is also given. F is 500 Hz. Now first is characteristic impedance. So Z0 is equal to square root of R by omega C angle 45. That is equal to 45 by 2 pi f is 500 into 0.065 into 10 raised to minus 6 angle minus 45 degree. So value of Z0 is 469.43 angle 45 degree ohm. This is the value of Z0. Next, attenuation constant. Attenuation constant, alpha is equal to phase constant beta, that is equal to square root of omega RC by 2. So alpha is equal to beta is equal to omega is 2 pi into f is 500, r is 45, c is 0.06 to 10 raised to minus 6 as it is micro, divided by 2. So this value is alpha is equal to 0.0677 Nepal per kilometer, and beta value is same but the unit is different, radian per kilometer.